Alright, here's a more involved problem involving phase changes. Calculate the enthalpy change when 25 grams of ice at negative 20 degrees Celsius is heated to liquid water at 38 degrees Celsius. So all this data right here is coming from this file called Physical Constants in the Content folder. Alright, the heat capacity of ice is different from the heat capacity of liquid water, and the heat of fusion is what we use for melting, whereas heat of vaporization is what we use for boiling. So we've got three calculations we have to do first. The ice is at negative 20 initially, so we've got to heat the ice up to its melting point. So that's a Q equals MC delta T calculation. Then we've got to melt the ice. Now remember, at the melting point, the temperature does not change, because during a phase change, the temperature stays constant. So we're going to melt the ice, so that Q calculation is Q equals N times heat of fusion. So that's N is number of moles in heat of fusion right there. And then now we've got all liquid water, but we've got to increase the temperature to 38. So that's a separate calculation. Q equals MC delta T. This time for the C, we're using the C of liquid water. So three separate calculations. So first we're going to heat the ice from negative 20 to 0 using Q equals MC delta T. So 25, now again we're using the C of ice, excuse me, the heat capacity of ice. Alright? And then delta T is final minus initial. Right? It was initially at negative 20, now it's at 0. So I converted everything to kilojoules, that's my preference. Now we're going to melt that ice, so that's where we use heat of fusion. So 25 grams, convert it to moles, use the heat of fusion from my data table. There's my number of kilojoules required to melt the ice. And now once my ice is melted to all liquid phase, we need to heat it up to 38. So another Q equals MC delta T, this time using the heat capacity of liquid water. So that's the 4.184. And so we come up with 3.971 kilojoules. Add those all up, round to two significant figures. 13 kilojoules is my final answer.